I like to talk about astronomical doom, and I emphasize the subtitle that it's a lighthearted look at the fate of everything, right? I'm a very happy kind of guy, and so, you know, I see the good side of everything. But first of all, I did also promise that it would be interactive, because that's just how I teach. I'm not one to just stand up here and talk. And so I have a few key words that I want you to listen to throughout my talk. So the first phrase, if you ever hear me say, "That's what we think," all right, I wrote it up there for you. That's what we think. You guys are going to respond all together, say, "How do you know?" Okay? So we'll try this one more time. So, that's what we think.
How do you know?
Beautiful. And then I will give you some evidence. All right, I'll show you, some kind of evidence. And then I'll ask, well, what do you guys think? And that's when you get to vote. And so that's what these cards are for. So you can tell me, you're going to be all scientists today, and you can say either, "Yay, science!" Or if you're not convinced, then you get to say, "Needs more evidence." All right? So you get to choose. And if you're completely confused, you can hold up both. That's totally, "I don't know" is an okay answer. All right, so just to make sure you guys got this down, let's go ahead and try this. I'm going to make a claim. The Earth is round, okay? At least that's what we think.
How do you know?
You guys are so good. All right. Well, how do we know? Okay, well, I have some evidence. I hear that everybody tells me that it's round. All right, what do you guys think about that? Needs more evidence. All right, I didn't convince you guys. All right. Yeah, good. All right, here's some more evidence. So, well, first of all, you have ships that appear from the top down if they're coming towards us over the ocean, and we can predict that. And we can also see different constellations in different parts of the Earth. All right, so you wouldn't, if you had a flat Earth, you would see the same stars in the sky. But also we have the sun rising and setting at different times. You have time zones, right? Would you have time zones if the Earth were round, or if the Earth were flat? So based on this, what do you guys think now? Is that better? Did I convince some of you? All right, yay science. All right, I'm seeing, I got enough. All right. Or yes, you could just take a picture, right? And we have, so that's cool. Yay science. All right, so now I can start my talk. So astronomical doom. And so I know what you guys might be thinking. This first image that I'm showing here, right? You're like, wow, you're really starting dark. It's like the destruction of the Earth, right? But no, this is not actually the destruction of the Earth. This is an artist's interpretation of not the end, but the beginning. So what you're seeing here is the birth of a solar system. Because in the early solar system, as the sun is forming out of this big cloud of gas, you have a lot of heavy bombardment. You have tons of rocks smashing into each other, and we think that Earth actually formed in this early bombardment stage. We think that it was impacted by a massive object that then created the moon.
How do you know?
So good, getting ahead. You're right to ask. All right, fine. At least that's what we think. All right, good. You're on top of it. All right, so how do we know? Well, here, let me show you some evidence. So first of all, if you look at the stars tonight, and even though it's cloudy at the moment, it is supposed to clear up. I just was checking the weather closely. You can see a constellation if you look towards the south, and it's called the Orion. Well, the constellation is Orion, and you'll see right underneath the 3 stars in Orion's belt, there's a small, faint little object, let's see, right there called M42. And M42, if you look at that with a telescope, and we do this regularly up on the roof, you can see a star-forming region. And inside that star-forming region, Hubble has taken images of around the stars. You actually have these dust clouds and debris that are forming these planets. So we've actually been able to image some of this, which is truly spectacular. All right, so maybe is that a little more convincing that we can actually see solar systems forming? And wait, let me give you one more, because I talked about the moon, right? And well, how do we know that the moon was bombarded and came off of the Earth? Okay, so a little more evidence comes from geology. Because geologists have shown that lunar rocks can form from a magma ocean that would be caused by one of these giant impacts. Also, you have elements like oxygen that come in the same ratio on Earth and the moon. And these ratios are unusual in other locations in the solar system. We've looked at the ratios of these isotopes of oxygen on Mars and on asteroids, and they aren't the same. But the moon and the Earth, they share this same chemical makeup. Also, we have computer models that can model this smashing of the Earth, of the early Earth, and that formation of the moon. So all of this combined gives us that model of the Earth forming along with the moon in this early heavy bombardment stage of the solar system. All right, so, okay, what do you guys think about that? Now is that, yay, science, that's good stuff, right? All right, good. Thank you. Okay, so yeah, so we have this early stage of heavy collisions. And it does settle down a little bit after the solar system has been living for a little while. And we still do have some collisions, though. And there's a particularly famous one that caused problems for our early ancestors. And in fact, you can see, this is not the crater that killed the dinosaurs. This is out in Arizona. You can see this meteor crater. It's really spectacular. But we think that there was an early collision about 63 million years ago that wiped out the dinosaurs. At least that's what we think. You guys are just, you're reading my mind. All right. How do you know? All right, let me give you some evidence. All right. So first of all, we can see there is right around this region of the Yucatan Peninsula, you can see an impact. If you look at with radar, you can see there's a small, oh, I lost my laser pointer. There it is. There's not a small thing. It's a massive circular impact site right there that's partly on land and partly on the ocean. And that impact site we can actually date using radiometric techniques, the same techniques that we use to do lots of carbon dating, things like that, only we use a different element. And we've actually dated this with about 6 different types of radiometric dating. And inside this site, that dates back to around the same period of that 65 million years ago. And we've noticed that there are fragments that are found all the way across the Earth. So that's 2 more pieces of evidence. And a third strong piece of evidence is that these impacts, when you have asteroids coming from space, they have a lot of an element called iridium. And iridium, it is commonly found in the Earth, but it's only a very slight amount, like 0.4 to 0.6 parts per billion in the soil around the Earth. But in this particular layer, when we go back and look on the geological record, there's a layer of about 400 parts per billion in that particular age. So, and that is this higher chances of iridium that are commonly found in these asteroids, like I mentioned earlier. So how's that for evidence of this early, destruction of the dinosaurs? All right. And I should say that, there was also a recent flyby. This is not just a long time ago that we get these meteors, right? These could happen at any time. And in fact, just I think it was yesterday, right? Kenny knows he's been keeping up with the news too. Yesterday we had a flyby of an object that was maybe it could have been about 100 meters in diameter. So imagine the size of a football field that came between the Earth and the Moon. And by the way, I have, just for scale, to get a sense of how close this was, so my Earth is over here, and to give you an idea of where the Moon is in relation to the Earth, a lot of people think the Moon is pretty close. It's further than you might think. So I have a model of the Moon. I know what you might be thinking. You say, that's no moon, that's a space station. but no. But this is about the right size. It's the scale size to be the moon. But if I were to have this be the moon, it would be located about here, roughly, in terms of that being the Earth and this is the moon. And that meteor that flew by yesterday, that was a size of a football field, came about halfway between the Earth and the Moon. So that's pretty close. It's a little nerve-wracking that we didn't know about it in advance. So there was another one that we didn't know about in advance, and that actually did impact us right after Valentine's Day in Chelyabinsk. Russia's really big, so when there's, I should say it didn't quite impact. It was kind of a glancing blow. It went and exploded in the atmosphere about 18 miles up. And it was only about 20 meters. So it was not as big as the one that flew by yesterday. And I have a little video to show you so you can get a feeling of what it's like to see or experience around this, because in Russia they have a lot of security cameras and dashboard cameras and things like this. So I'm going to play this video so you can see the cloud above, right? Yeah, it's loud. And that was actually the main problem. Fortunately, no one was killed. But there were a lot of injuries, because what happens is that you see the light, you see a flash of light because the light travels faster than sound. And after that flash of light, then the sound shockwave comes through afterwards. It's one of my favorite parts of this clip. Pressure of the air, right? Just from the sound.
Ну что, ребята, счастливого, счастья.
So one of the lessons to take from this is that when you see a flash of light outside, don't walk to the window. Because there's the flash of light, right? And so you're tempted to go see what's going on. But then the sound travels afterwards, and when the sound travels and breaks the windows, glass can go shattering, and there's the glass going. So the injuries that were sustained, there were some minor injuries, mostly due to glass getting into people. So yeah, this would be pretty terrifying, as you can imagine. But let me just flip this over. Whoops. Sorry. There we go. I thought you said this was a lighthearted talk, right? Sorry, no. This is okay. I mean, after all, you know, the roots of all comedy is tragedy, right? And what could be more tragic than the end of everything? But we're talking too small here, right? Because I'm still talking about just Earth impacts. And we can go bigger, right? Because the Earth is going around our sun, and I promised you the fate of everything. So let's talk about the fate of stars just for a moment, all right? So our sun is something like this star right here, and it comes from a big cloud of gas. I mentioned at the beginning of the talk that we have this massive cloud of gas that collapses down, and our Earth is forming right around that same time. And that's when we get our sun-like star. And don't be intimidated by this chart. This is, I'll try and go over it slowly, but if you need more assistance with it, I encourage you to take my class. It's all about this. So once our sun is formed, it's going to stay in its main sequence, or it's going to stay burning hydrogen into helium for about 10 billion years. So we have a good long stretch, and our sun is about middle-aged. But as it gets on in its years, it starts to expand, like a lot of us, and it becomes this red giant stage, right? So this red giant stage is when it starts to have fusion of elements in a shell that gets closer and closer to the surface, and it starts expanding out, and it basically throws off its outer layers of hydrogen gas and gets this beautiful object called a planetary nebula. And we can look out at these things in the night sky and see lots of different types of planetary nebula. And these are these big gas clouds that are throwing off their outer layers. And the remnants right here is this white dwarf. This is going to be the leftover, which is like the core of our sun. And that'll happen over the course of the next 5 billion years. So it's going to take a long time. 5 billion years is nothing compared to the lifetime of all of life on Earth. So we have plenty of time. The other type of death that stars can go through is if they're a much larger star, the star will become this massive star. It tends to have a shorter lifespan. The bigger it is, it's kind of like a big bonfire that burns out quickly, as opposed to a small candle that just burns for a long time. And so a big massive star goes through something that is called a red supergiant stage, because astronomers just call things like they see them. It's red, it's super, it's giant. And that leads to a supernova, which is a massive explosion, much stronger explosion than you would get going into this planetary nebula stage. These supernovas, they can outshine an entire galaxy. Really spectacular. And so a lot of the supernovas that scientists are studying, like my wife is an astrophysicist studying these things, they'll look at them outside of our galaxy, out at other galaxies. And these things can result, depending on how big they are, in a neutron star or a black hole. So that's the death of all stars for the most part. Now, it's not quite that simple, because you can have things get a little more complex when you have companion stars. So I have a little animation to show you. Okay. So if you have a companion system, you can actually have two stars in orbit around each other. So this is an example of a white dwarf and a red giant next to it. And if they're close enough, you can get some of the material from that red giant stage siphons onto the white dwarf, and that gravitational attraction causes another supernova. So even though neither of those stars individually can go supernova, combined they have this symbiotic relationship that can cause this explosion. Now we're not quite certain if it's that type of supernova that we're seeing, or perhaps there may be two white dwarfs that are merging together as well. This is another possibility, that perhaps there are these core of the stars that are in orbit around each other, and we're going into a planetary nebula right now. So if we zoom in on a planetary nebula that had two white dwarfs, they can actually merge, and when they merge, they can go supernova possibly as well. So between these two possibilities, this gives you a good sense of the fates of most of the stars that we see. And of course, what of Earth then, you might be wondering, all of our favorite planet? Well, it's not good news. Certainly the Earth is quite likely to be burnt up to a crisp. And right now we think that when we get to the red giant stage, that will probably still be outside of the red giant. So at least that's what we think. How do we know? All right, you just didn't forget. Good. It wasn't too long. So one of the ways, we have some simulations that we can do, and there are lots of different ways of modeling, doing computational modeling of gravitational interactions and modeling as the star is expanding. So here's an article that was submitted in 08. This is peer-reviewed, and these authors are commenting about how our sun is going to expand and about how big it's going to be, and actually I have to correct myself. Their findings was that planet Earth will not be able to escape engulfment in order to survive. So this is all based on computational modeling. So what do you guys think? How do you feel about that? See, a lot of needs more evidence. Yeah, I think this is an open question in research. I think this is not settled. Computational models, depending on how sophisticated they are, they might need a lot of work. And also, I didn't give you much information that you could judge yourself. Maybe if you were in the field, you might be more convinced. But I also feel the same way. I'm not convinced either way at this point. But I am pretty convinced that Earth itself is not going to be pleasant to be on. But again, so we've talked about the fate of Earth being impacted, what's going to happen when our sun gets into that larger stage. But let's go bigger, right? We have galaxies. So Earth is inside our solar system. Our solar system is just a small piece of our Milky Way galaxy. And then our galaxy is a part of a local cluster of galaxies. And so what about all of those, right? Surely we have some good news in the end about after a few more billion years, maybe our sun will go away, but what about the rest of the galaxies? Well, there's a few possibilities and a few proposed ideas. One of them, if you take all the galaxies, you might have something called the Big Crunch. So what we see right now is that these galaxies seem to be rushing away from each other. And so it's possible, they might think that, well, maybe these galaxies are going away from each other, but then they're going to come back and kind of do a reverse Big Bang, right? So this is the idea of the Big Crunch. Now this has been essentially ruled out based on our current evidence. I'll talk about that in a bit. But another possibility is, well, maybe there's this big chill, I like this name, where instead of having the galaxies all come and crush back together, they just expand away from each other and just stay coasting along and get further and further apart. But locally, they might stay bound into their own local galaxy. So then there's another possibility, which is called the Big Rip. And again, astronomers coming up with names. And the Big Rip, right, it's kind of what it sounds like. The idea being that we have this expansion of space and time. So space itself is expanding, and that galaxies are going away from each other because space itself is stretching. And if this stretching happens even on a local level, then that galaxies themselves, even down to the atomic level, could just rip apart. So these are, the second two are sort of where we're leaning. At least that's what we think. How do you know?
Based on what?
Based on what? Yeah, I mean, I gave you some hypotheses, I had a graph, but what is the actual evidence, right? What is the evidence for this stuff? And I'm glad you asked, but you might be sorry you did. So here's the idea. It's based on something called the Doppler effect. And you've all experienced the Doppler effect, because when you hear a car driving by, if you think about what the sound makes as a car drives by, it starts high and then it goes low. Don't worry about the volume, just think about the tone. And I'll do it for you, right? So my students always appreciate my impressions. So, all right, car coming towards you. Right? So high, low, right? That is the Doppler effect. Thank you. So what's happening is that as the car is coming towards you, those sound waves are getting compressed. And that's what a high pitch sounds like. Well, if light is coming towards us, it gets compressed as well. But when it's going away, the low pitch, that's when things are going away from you. And so if a galaxy is going away from us, we can see the light get stretched out in a way. So, and when I mean this light stretches out, I mean that the wavelength of the light can change its color to go from, for example, this yellow wavelength can go to a more red wavelength, which is a more stretched out wavelength, okay? So we can see the galaxies appear to change color a little bit, the light from them, and they get redshifted, we say. But it's not the same redshift. If you just have a galaxy going away, we can predict what the wavelength looks like when that happens. But if you have space itself expanding in between the galaxy, the signal will look different. You actually have this broadening. So even though these might be going at the same speed now, this thing is actually going faster and faster, and so you get a different signal. So this is the evidence, some of the evidence. Let me give you one more piece of evidence. I told you you'd be sorry. And this is from supernovas. I talked about supernovas. So we can look at the galaxies, but the supernovas, when we look at their redshift, we can predict based on what the expansion rate of the universe is. We can have these different lines representing different consequences for the universe. So anything that falls down here in this pink region, this would be if the universe were decelerating. All of these supernovas, these are data points from those exploding star deaths. Those data points should be down in this pink region, all right? But But if it's accelerating universe, if the space itself is expanding more and more rapidly, then it's going to be up in the blue. And you can see they do fall into this blue region. Not a ton. We're just near the line, but enough to make us fairly convinced, and at least enough to earn a Nobel Prize in physics. So how's that for evidence of the expanding universe? Is that convincing? Oh, you guys are a tough crowd, tough crowd. All right, so good. At least we can eliminate the big crunch. All right. So in either case, whether you have this big rip or not, whether the space itself is going to rip apart or if the local galaxies are going to stay together, but still we're stretching out. And in any case, the fate of the entire universe is going to be dark, right? So I dressed appropriately. But again, I promised you lighthearted, right? Okay, so here is a light heart. So yeah, this is a real image, but you know that the universe constantly surprises us, and so there are some other ideas out there that maybe the you know, space might have a few surprises up its sleeve. And recently, you may have heard of Stephen Hawking passing away, and he's a brilliant physicist. And in flipping through news articles at the time, I came across this one, and the heading was, "Stephen Hawking's final paper predicts the end of the world and revealed a parallel universe." What do you guys think about that one? I'll just go straight to the vote. Needs more evidence. Yeah, fully on board with you on this one. I intentionally looked for the worst, you know, headline, the most outrageous headline. And so that's from this reliable news source, news.com. I don't know if that's reliable or not. But you know, I read the paper, and the gist of it is definitely not anything about a discovery of a parallel universe. And it doesn't really address the end of the world. But it is about this idea of multiple universes and parallel universes. He's trying to come up with a way to get around the idea of having infinite universes. So he was trying to eliminate this idea of infinite universes and limit to only having, you know, a finite number, potentially, of infinities. It gets really weird. So suffice it to say, this is you know, interesting ideas, but that's what physicists are filled with, and we're still looking and trying to find answers, and we're constantly looking for more evidence, right? And we're just trying to fit our best model to the evidence. But in any case, you know, whether we have universes abound and our fate of the universe is dark. I know that the universe is a wonderful place, and we are so privileged to be here, and it always just makes me happy, and I think you should enjoy it too. All right, thank you very much.